All right, we're going to talk a little bit about applications, and I think we can go through this pretty quick because a lot of it's just kind of going to be material that you could refer back to. You know, you say, hey, I've got a reciprocating compressor. What kind of test package should I run? You know, I'm a transmission. Do I need to run particle count? Should I run PQ? Things like that. So what I'm going to do go through here is just different applications. And I'm going to talk a little bit about sampling intervals, how you determine what those should be. We give you some ballpark guidelines to get started on sampling intervals. There's a handout on that flash drive that talks about sampling intervals for different types of components. And then we're just going to give you basic versus advanced test packages. I will tell you that I rarely ever recommend a basic package. The reason being is that for a few dollars more, you can get an advanced test package and get so much more information. The only time I typically would recommend a basic, and where I've seen it happen, is if you get into a state bid or something like that, and they limit you. They say, hey, this is what we want for oil analysis. These are the tests we want. And usually it turns out to be a basic test. I don't see them doing a lot of advanced testing. So I always say, go for the advanced test package. It's money well spent. So under mobile applications, we're going to look at engines. We're going to look at diesel and gas, actually just diesel engines. I need to change those bullets. We'll look at transmissions, hydraulics, and then gear systems. What I want you to notice here is these are mobile engine sampling intervals. We got over-the-road trucking, we've got city pickup and delivery, city bus fleets, refuse or trash haulers, construction, and mining. What do you notice about the sampling intervals as you go through those different applications?
The time frame is the same.
What's that?
Time frame is similar.
Similar, but as you get more into more severe conditions, think about it. Over-the-road trucking, you know, that's pretty easy on the engine running down the road. But if you take that same engine and you get involved in trash hauling, a lot of stop and go, stop and go, stop and go. Typically what I want you to take away from the slide is the more severe the application, the shorter the sampling interval, okay? So that we want to stay on top of that trend. We want to catch anything that's likely to happen in a more severe application. But these are just some ballparks to start with, what we recommend for the different types of industries that we test for. You're going to see a bunch of these slides. And these are going to be really just reference slides for you to go back to. I always list the basic package, and then I put the advanced. You hear about EDI, extended drain interval, ESI, extended service interval, and then the latest one since I started here is OSI, optimum service interval. Believe it or not, we actually have some customers that we start with, and we say, you know what, you're overextending that oil. You need to shorten your interval, okay? So that does happen. So we want to find that optimum service interval. What's that sweet spot for your application? So those are the differences of the test packages there. Typically what you're going to see is we're always going to do metals, water, and viscosity on all these tests, whether it's basic or advanced. So you're going to hear me saying that over and over and over. Metals, water, and viscosity. And then for the engine, we're going to do fuel and soot because we know that's going to affect the viscosity. And then we're going to do a base number. Why do we run base number? Because we want to see where it starts and where it's at, and that's going to tell us what? The additive level. What's it going to tell us about the additives in the oil? Yeah, it's going to tell you how much has been used, how much is left. Okay, so we're going to use that base number to tell us, hey, it's time to change that oil out, or no, it's still good for continued service. If it starts at 8 and it's at a 4, we're still good. When it gets to 2.0, we need to think about changing that out. And then I will tell you that acid number is starting to come into play with some oil companies. They like to see acid number as well. All right, transmissions, we give you some sampling intervals here that you can refer back to. Again, these are just ballpark ideas to get you started. When we look at the transmission, where do we go? There we go. Basic and advanced, we're going to do metals, water, viscosity. We're going to do acid number, and we're also going to do isoparticle count and particle quantifier, okay? So the isoparticle count, we're going to look for, what rating is it, 26, 18, 13, whatever it is. We're going to look at the PQ, how much ferrous material is in there, how large is it. So, we typically run the isoparticle count and the PQ. If you just wanted to run isoparticle count, I'd be okay with that. But we're going to do the advanced testing. On the mobile hydraulics, a lot of times the equipment can be exposed. When I first got into the petroleum industry, my boss used to work with excavating equipment. And he told me one time, he said, Henry, when you've got a situation like this, and maybe you've got a reservoir that's exposed to the environment, he said, what can happen a lot of times, that reservoir, we talked about what's the purpose of a reservoir is to allow that product to cool down a little bit, okay, settle out any contaminants, but to help it cool down. He said if you get 1/4 of an inch of buildup on the outside of that reservoir, let's say it's oil and grime and dirt, you get a 1/4 buildup. He said you increase the temperature of that reservoir, that oil in that temperature, by 20 degrees. Well, why is that important? When we were talking about hydraulics, what did I say? Everything above 140, 18 degrees above, you cut the life of that oil in half. So if you get a 1/4 buildup on that cooling reservoir, what it's going to do is going to cut the life of that oil in half. So I thought that was pretty interesting that he would share that from the real world. Okay? And usually with these hydraulics, we're worried about this stuff we can't even see, 2 to 5 microns. It's going to get into those clearances and going to cause us all kinds of issues. Varnish, that's something that the industry is starting to talk more and more about it. We do have some testing that we run for something, it's called varnish potential. And so we're going to look at that to say, okay, what's the remaining life of this oil? When it gets down near the end of the life, that's when you can see varnish start to happen. There's another test in there that we run, membrane patch colorimetry. And we look at the color of the patch. As it gets darker in color, it goes from yellow to gold to brown. As it gets darker, that's an indication that you could have varnish potential. And then we run another thing called a linear sweep voltammetry. And basically we're seeing how much oxidation inhibitors are left in that oil. What's the remaining useful life? So varnish is coming along. It's really starting to be popular. People are looking for it. And it's amazing. It's usually less than 1 microns, but it can cause you a lot of trouble. And especially if you catch it early, you can clean it up. You catch it late, it's really hard to get it out of there. Okay? All right. So for mobile hydraulic systems, we're going to do agriculture, construction, mining. We give you some sampling intervals there. And then the test package I like to see run on hydraulic systems is metals, water, viscosity, and then I want to see acid number. I want to know what's the condition of that oil. If it's a hydraulic oil, it starts at 0.5. I want to know what that acid number is, because when it gets to 2.0, I'm going to change it out. Then I also want to know the isoparticle count. How clean is that oil? Okay. So, and then gears. Gears seem to be a little bit longer in their sampling intervals. A lot of times they're not quite as critical as some of the other components we've looked at. But here's some gear sampling intervals that we give you as well. In terms of advanced test package for gears, I want to see metals, water, viscosity, acid number to tell me what the life of that oil is, where it's at in its life stage, and then I want to see the PQ. Because on gears, we know that they notoriously, when they start to wear, they get into the 10, 20, 30, 40, 50 micron range. That's not going to show up on our elemental metals. We need to see that with the PQ. Okay? Now, this is natural gas engines, turbines. I'm going to jump over that because nobody has natural gas, nobody has turbines. I will jump to the compressors. Okay, so if it's a rotary screw compressor, I want to see you running metals, water, viscosity. Water by Carl Fisher, if you want to know absolutely how much water is in that. I don't think that you have to run that. If you just run a water, I'm okay with that. And then an isoparticle count and a particle quantifier. Definitely an isoparticle count. I'm not so sold that you have to have a PQ, but that's part of the advanced test package. Reciprocating compressor, metals, vis, water by Carl Fisher, acid number, isoparticle count, particle quantifier, and then oxidation nitration. Oxidation nitration can tell you the useful life of that oil, how much time's left, just like acid number. So it's kind of a side-by-side comparison. They're both going to give you essentially the same information. So if you wanted to drop oxidation nitration and just use acid number, I'd be okay with that. This is a centrifugal compressor. Used to see these in the coal mines back home when they're moving a lot of air through the underground mines. For that type of compressor, we're going to see metals, viscosity, water by Carl Fisher, acid number, and particle count. Now, I went through those really quickly because they're just more reference, just to look back and say, what kind of test package, should I be running on these? So that's why I shared those. Now we're going to get into data interpretation. I'm going to move over here where I can work off of the computer. Now we're going to put together some of the stuff that we hopefully have picked up today.